This is the first video for the lesson Uptown and Downtown, Exponential Equations for Growth and Decay. This is from the topic Using Exponential Equations. You are already familiar with the structure of both linear and exponential equations. Now we're going to explore the difference between the two through the context of simple versus compound interest. So let's begin by defining each of those key terms. Simple interest uses the formula I equals PRT. I stands for interest, P stands for principal or the initial amount, R is our rate as a decimal, and T is our interval of time. For compound interest, we use the equation I equals P times the quantity 1 plus R to the power of T. Those variables mean the exact same thing. One thing to pay close attention to is for simple interest, this I here for interest is only the interest. So if I want to know the balance of the account, I will have to add that back to the principal. However, for compound interest, using this I here, that does represent the balance in the account overall. So we will not need to go back through and add a principal because this formula for compound interest is related to the entire amount in the account year over year. Let's go ahead and take a look at these in the context of a real example. So we're going to consider two accounts here that each have a beginning balance of $500. So that's our principal or P. One account is going to earn 3% simple interest each year. The other account will earn 3% compound interest each year. So let's go ahead and start with our first table. And this one here is all about simple interest. So thinking back to the formula that we just discussed, our formula for simple interest is I equals PRT. Now remember, I am looking for the balance here. So that means, as we discussed, I'm going to have to add that principal back on. And our principal, as is stated in the problem, is $500. So in order to determine the mathematics here, our arithmetic is going to be 500 plus PRT. So the initial balance plus the interest. So let's go ahead and do that at time 0, this first row here. So I'm going to go ahead and substitute my information in. So I've got 500 plus principal again is 500 times our rate as a decimal, 3% as a decimal is 0.03. And then in this particular case, our time is 0, so also known as the initial amount. So now I have 500 plus, when I multiply all of that together there, I am just going to get 0. So that is going to give me 500. And that makes sense because that's the initial amount. We're going to do that exact same arithmetic for every single row after that. So we're going to take that and substitute in a 1, and we get 515. When we substitute in 2, there's our mathematics there. We get 530. And then we'll do the same thing for 10 and 100. Now that last row is asking for me to come up with a general formula. So that means for any time t, what will that look like? So I'm going to use the exact same formula that I've been using here. So we're going to take 500 plus my principal, which is 500. My rate is 0.03. And then we're using t for time because we're not given a specific value there. When I simplify this, I get 500 plus, as I complete this multiplication here, I get 15t. Can't simplify that any further, so that ends up being my general formula here. Now we can do the exact same thing for the next table, this table down here, and this one is all about the compound interest. Now, that formula that we discussed earlier is going to be I equals P times the quantity 1 plus R to the power of T. Now remember here, this formula does in fact give us the balance in the account, so there's nothing else that I'm going to have to add to it. That's all I'm going to need. So let's go ahead and substitute for the first row here, when time is equal to 0. So I'm going to take my principal, 500, times the quantity of 1 plus R, my rate as a decimal, 0.03, to the power of 0, because that's the time for this particular row. So I will have 500 times the quantity 1.03 to the power of 0, and I got that simply by adding what I have in my parentheses there. I know that anything raised to the power of 0 is 1. So that means this math problem here is really just 500 times 1, and that equals 500. Again, that makes sense since that is my initial value when time is equal to 0. We're going to do that exact same arithmetic for each of these rows here. So we have when time is equal to 1, when time is equal to 2, 10, 100. And now let's go ahead and talk about what will this general formula look like. So I'm going to go ahead and substitute again. My p-value, my principal, is 500 times the quantity, 1 plus the rate, 0.03, to the power of t. When I add what I have in my parentheses there, I end up with 500 times 1.03 to the power of t. So that is going to be my general formula. Let's now take a look at what each of these scenarios looks like graphically and compare those to each other. So on this slide, the table here is just bringing together the information from the two tables on the last slide. So we have simple interest balance in this column here, and then compound interest balance in the column all the way to the right. And then time in years is over here on the left-hand side. When we graph that simple interest, what we end up with is this linear function here, and you can see it's labeled with the exact function that we developed on the last slide. When we look at the compound interest, we get this curved function here. That's our exponential function. And again, our equation matches up perfectly there. Please be sure to check out part 2 of this video.